4. Give me 1 second. I'm gonna try to readjust this. It's looking a little blurry. Let me try to pull this out a little bit. All right. Okay, so this is week 24, day 1. Find the sum of 2/3 and 5/12. The first thing I need to do is get least common multiple. So my least common multiple between 3 and 12 would be 12. So that would change my fraction from 2/3 to an equivalent fraction of 8/12. Add the two together, that gives me 13/12. I need to change it to a mixed number, and that gives me 1 and 1/12. The second part, find the difference between 2/3 and 5/12. Since I've already found my fractions, all I need to do is subtract. So 8 minus 5 would give me 3 over 12. I reduce that to 1/4. Number 2, Maurice bought 1.5 yards of material for a school project. He found that it wasn't quite enough to finish, so he bought another 3/4 of a yard to complete the project. How much fabric did he use? Write an equation. So what I'm really looking at is I see that I bought 1.5 yards, and then I needed another 3/4 to complete it, so that's asking me how much did he use. Well, if he used 1.5 and 3/4, I need to add. So I need to get a least common multiple, which is 4. So that only impacts this fraction. That becomes 1 and 2/4, because 2/4 is equivalent to 1/2, just has the denominator of 4. I add those two together, and that gives me 1 and 5/4, but 1 and 5/4 is a mixed number, an improper fraction. So I have to divide 4 into 5. That gives me 1 whole and 1 left over. So now my new fraction is 2 and 1/4. So that would be 2 and 1/4 yards of fabric he used. Remember, if it has words, I have to answer in words. Okay, number 4, the Cake Boss recipe calls for 2 and 3 2/3 cups of sugar. He has been hired to make a wedding cake. It takes 9 cake recipes to make a wedding cake. How much sugar will he use to make the wedding cake? And then it asks, can you think of another way? Well, the first thing I need to realize is if I'm making 9 recipes, then that would be repeated addition. It would be 2 and 2/3 9 times. So instead of repeating this 9 different times, I can multiply it times 9. So I change this to an improper fraction because I can't multiply 9 times 2 and then have 2/3 left. That wouldn't be correct. So I change this. This is 2 times 3, which is 6, plus 2 is 8 over 3 times 9 over 1. I just changed this to a fraction. I quickly reduce this because I can see that if I cross simplify, that would make it easier for me. I won't have to divide when I'm done. So I can divide 3 and 9 by 3. 9 divided by 3 is 3. 3 divided by 3 is 1. I can't cross simplify here. So now I can just multiply. 8 times 3 is 24, and 1 times 1 is 1. So that gives me 24 cups of sugar. Now, is there another way that I could do that? Yes, I could divide 2 and 2/3 by 1/9. Okay, and if you remember, keep, change, flip, you may notice something. I keep 2 and 2/3, I change the sign to multiply, and I divide, and I flip 9 over 1 to 1/9. So yes, there's another way of showing that. Day 2, write 6 and 2/10 as an improper fraction. Again, you just multiply. 6 times 10 is 60, plus 2 gives me 62 over 10. Write 10 divided by 15 as a fraction. That would just be 10 over 15. Write 4/3 as a mixed number. I would divide 3 into 4. That gives me 1 whole with 1 left over. And then my denominator stays the same as 3, so 1 and 1/3. Number 2, the length of Matthew's spring garden is 2.5 times longer than his winter garden. So I just drew a picture. Here's his winter garden, and then his spring garden is 2.5 times longer than whatever his winter garden was. Okay, so what if the winter garden, now it gave us 8 feet as the winter garden's length is 8 feet. Then what would the length of the spring garden be? Well, the spring garden would be the winter garden's length times 2.5. So I just plugged in my 8, since I knew my length of the winter garden, and multiplied it times 2.5. 2 times 2 is 4, plus 1 is 5, so now I have an improper fraction, and now I can multiply. So I set it up as 8 over 1 times 5 over 2, and I'll look immediately and I see that I can cross simplify. So 8 divided by 2 would be 4, and 2 divided by 2 is 1, so that would just give me 20 over 1 when I multiply 4 times 5. So the spring garden is 20 feet in length. Number 3, it says solve for M. Remember, think fat families. If I have 4/5 times something that I don't know equals 1, well, what can I do to figure out M? Well, let's go back to our whole numbers, things that we learned back in first grade, kindergarten. We learned about fat families. So let's try a whole number. If I had 10 times something and it equaled 30, how could I figure out what this something was? It's kind of set up the exact same way. I have a number, I have an unknown, and then I have a product. Well, what could I do? I could take my product and I could divide it by one of the factors. So that's what I'm going to do. I take my product, which is 1, and I'm going to divide it by the factor that I have, which was 4/5. So I'm going to try the keep, change, flip when I divide. I'm going to keep 1. How can I change that to a fraction? Just put 1 over 1. Times, now I'm going to flip 4/5 to now 5/4. And 5/4 times 1 gives me 5/4. So M would be 5/4. Now let's try it and see if it works, okay? So now I'm going to take 4/5 and I'm going to multiply it times 5/4. 4 times 5 is 20. And look what I have again. 5 times 4 is 20. So 20 over 20 equals 1. So that checks out. Okay? Now I have the exact same thing over here. I have a factor times an unknown equals this product. Well, what can I do? Remember, I can do the inverse, just like I did down here with whole numbers. If this is my product, I'm going to take it and put it in the front. Now I'm going to divide it, instead of multiplying it, by my unknown. And now I'm going to apply my little trick that I use when I multiply using reciprocal property. I'm going to take 5/8, I'm going to change the sign to multiply, and then I'm going to flip 5/8 to 8 over 5. Now let's multiply. I have 5 times 8, which is 40, and 8 times 5, which is 40. So this is telling me that W equals 1. Well, that would have to make sense, right? Because if I have 5/8 over here and I multiply it times 1, then it gives me 5/8 over here as well. Looking at number 4, complete the table using the rule x divided by 7/10. So if I have 3 and 5/10 and I divide it by 7, it gives me 5. If I have 35 divided by 7/10, it gives me 5/10. Sorry, I'm saying it wrong. It gives me 5. I'm completely messing up. Okay, this gives me 5, and then this would give me 50. Okay, 350 divided by 7/10 will give me 500, excuse me for my blunder, and then 3,500 divided by 7/10 would give me 5,000. So what do you notice? What happens every time that I divide this number by a tenth, and this number changes to be more by a multiple of 10, this increases by 10 as well. So 5 times 10 would be 50, 50 times 10 would be 100, and then 500 times 10 would be 5,000. Okay, so let's look. If n equals 20, then 24 plus n divided by 4 equals what? So what do? I use order of operations. 24 plus 20 would be solved first because it's in parentheses. That gives me 44. Now I can work on what's outside. 44 divided by 4 gives me 11, so my answer is 11. If n equals 12, then 24 plus n divided by 4 equals what? So let's solve my parentheses again first. I plugged in my n first. So 24 plus 12 divided by 4 is how I would rewrite it. And now I would solve my parentheses first, which gives me 36. 36 divided by 4 equals 9. Day 3. When I model using decimals, remember decimals and fractions are the same. So I do the same thing with my model. 4/10 out of 100 out of, well, it would be 4 out of 10 going this way, and it would be out of 100 if I'm talking about my whole model. So this is 4/10, so I'm going to shade in 4/10 in my column. So that would be 4 out of 10 columns. Okay, now I have my rows, so I'm going to shade across 4/10 out of 10. My product would then be 16/100ths because I have 16 shaded in that overlap out of 100 total squares. So 16/100ths would be right. How would I write that as a fraction? It would be 16 over 100. Would be the same. Okay, so a fraction represents division. Which statement below is true? Well, let's look. I have 3 over 4, and as we call this is the cowboy, this is the horse. When the cowboy is off the horse, the cowboy leads the horse. So here's my 3 divided by 4. None of the other ones would make sense. Number 3, complete the following using mental math. So I have 82 divided by 1/10. So which direction would that push my number? It would push my number over one place to the left, and I would annex a 0. So now that gives me 820. This is going to push my number 2 times to the left, so that would annex 2 zeros. Now I would have 8,200. Again, 3 times to the left I would move, so now I annex 3 zeros. That gives me 82,000. 82 times 1/10. So what happens with my 10th? I have to place my decimal in one place over. So that would be 8 2/10. Hundredths, I would have to place my decimal 2 times. So slide it over 2 times, or slide my number to the right 2 times. And that becomes 82/100ths. This time I would slide my number 3 times to the right. So that would give me a place where I'd have to annex a 0, and it would be 82,000ths. Right, number 4. Over the years, Olivia has collected 17,698 pennies in a jar. In dollars and cents, how much money has she collected? Well, a penny is only 1/100th of a dollar, right? And so since I have to know that a dollar looks like this, there's one hole in the 10ths place. So how many of these would it take to get to dollars? It would take 100 pennies to get here. So I'm going to take this number and I'm going to divide it by 100. So I take 17,698 and I divide it by 100. When I divide it by 100, that slides my number 2 places to the right, correct? So then this number moves 2 places over here, so my decimal lands right there between the 6 and the 9, and that gives me $176.98. Evaluate. Remember, if I have anything to a power of 0, then this number becomes 1. So now I'm going to rewrite over here because this is order of operations. I solve my parentheses first, and I notice, wait, I have an exponent inside of my parentheses. So I'm going to solve that before I move on to the next level. So that gives me 3 times the product of 2 times 1 divided by 6. So now I can solve. 2 times 1 gives me 2. I rewrite 3 times 2. Why did I put a times there? Because there's no sign next to this number. So I'm going to now use my parentheses as multiplication. And because multiplication comes first right here, I'm going to multiply before I divide. 3 times 2 is 6. 6 divided by 6 gives me 1. So my answer is 1. Day 4, Mrs. Frizzle's family is going to Disney World over the holiday. She plans to spend 3 days and 2 nights in a hotel park. About how long will it take her to drive? 465 miles if she is able to drive an average of 62 miles. So I noticed something right here. I don't need this information right here. This is what's called unnecessary information. So I don't need 3 days and 2 nights. What I do need to know is that she is going to drive this many miles and an average of 62 miles. So I am going to divide 465 by 62 to figure out if I were driving the same speed, how long would it take me to get there in hours? Okay, so let's look. when I divide 62 into 465, I got 7, and 31 was left over 62. So 31, if I look at it, it doubles to 62, so that would be the same as dividing 31 by 31, which equals 1, and 62 divided by 31 would equal 2, so that gives me 7.5 hours it would take to drive to Disneyland or Disney World. Number 2, solve for n. So if I have a number here next to n, that means to multiply it, right? So this would be 72 times whatever this is equals 432. Well, how can I decide what n equals? Well, the same thing I did with fact families, right? If I am multiplying two numbers and I get this number, then I need to divide it by whatever factor I have that I do know. So I do know that 72 is a factor, so I'm going to take 432 and I'm going to divide it by 72. Now I'm also going to divide by 72 on this side because I only want to see n. So that leaves this as leaving me with 1. So 72 divided by 72 is 1, so I don't need to write 1n because 1 times whatever equals the same number. So I'm going to leave the n alone. Now I'm going to isolate this side and I'm going to go ahead and divide. So 72 can go into 432 6 equal times. So that n becomes n equals 6. Now I'm going to try it to make sure it works. If I multiply 72 times 6, what do I get? I got 432, and it worked. Okay, again, I have p divided by 2 5/10 equals 60. Well, think again, fact families. What do I know about fact families? If I have division here, what would that look like if these were all whole numbers? So I just drew myself a little example down here to help me remember what I need to do. So let's say I had 30 divided by 6 and it equals 5, right? So what do I notice? If I didn't know what 30 equals, what could I do with these two numbers? Well, I could multiply these two numbers and it would give me this. So that's how I'm going to set up this problem. I'm going to multiply this times this and see if I get the same thing. So I'm going to take 2 and, I'm going to see if I'm going to get what p equals. So 2 5/10 times 60 equals p. So now I'm going to multiply it, and that gave me 150. So let's try it and see if it works. I'm going to take 150, I'm going to divide it by 2.5, and when I did, it gave me 60. So this works out. 150 divided by 2.5 gives me 60. Remember, always write your fact families if you're not sure, especially when it comes to an unknown. How can I solve it? I'm sure you can figure it out with a fact family. Alright, so now I have a very long equation here that I need to solve. It's an equation because it has an equal sign. So I'm going to rewrite because I have exponent inside of here that I need to solve before I can solve my parentheses. So 2 to the power of 2 is 4 because 2 times 2 equals 4. So now I'll rewrite everything and then I'm going to work on solving. Well, inside of my parentheses is what I'm going to focus on first, and I have division, which comes before addition, so I have to divide first. 4 divided by 2 equals 2. So I rewrite everything, and now I still have something in a grouping, so I'm going to solve it. 9 plus 2 is 11. I rewrite everything. Now let's see, what do I do first? Well, I have subtraction, I have addition, and I have multiplication. Well, according to GMDOS, I solve multiplication first. So 3 times 7 is 21, and I rewrite everything in the front. Now, all I have left is subtraction and addition, and I solve whichever one comes first from left to right. Well, subtraction comes first. So 24 minus 11 is 13. So I rewrite 13 plus 21. Now I add and I get 34. So my answer is 34. Number 4, what is the effect of a product when multiplying a whole number greater than 1 by a decimal less than 1? Well, remember, just like when we multiplied fractions, like if I had 7 times 2/3. Well, 2/3 is less than 1, right? It's less than 1. So if anything I multiply times something that's less than 1, I'm not going to get this exact same thing. I'm going to get something less than my whole number. Well, let's look. If I have 72 times 4/10, well, 4/10 is the same as 4 over 10. It's not a whole number. This number isn't 10 over 10, so I'm not multiplying 72 times 1. I'm multiplying it times something less than 1. Okay, so if I can remember that, then my product is going to be less than 72. So the product will be less than the whole number. All right, and then at the bottom it says list all composite numbers that are greater than 16 but less than 36. So I just started writing down all of my odd numbers from that's greater than 16 all the way to 35, because 35 is still less than 36. So it has to be between 16 and 36. So when I wrote down each one of them, I checked to see which ones are composite and which ones are prime. Well, 17 and 19 are definitely prime, but 21 is not. It's composite. 23 was prime, but 25 and 27 are composite. Okay, so that leaves me with 29, 31, which are prime, and then 35 and 33 are composite. Have a good evening.